Hi guys, this is your learning coach Vinod. So happy to welcome you all to this special edition of the Astronomy Masterclass session. So happy seeing you all today on a Sunday. So what I really like in all of my students is that it doesn't matter whether it's a Sunday or a holiday. Okay, I know all of you guys are ripe for new learning, and whenever we have something good, all of you guys are in attendance. So thank you so much for being here. Okay, so first of all, a big shout out and a big thumbs up to all you guys who are here on a Sunday evening uh, because you wanted to learn something new. So that's it. Hi guys. So before we begin, why don't you guys quickly introduce yourself in the group to me, to all the others who are joining in from different parts, our country. Okay. So hi Pratana. Hi Akshara. Hi Sudhir. Hi Meg. Fantastic. Hi Kapish. Superb, guys. Aburvan is here. Happy to be have you here, Aburvan. Superb. Hi, Sheen. Hi, Neetu. Fantastic. Guys, tell me your name, tell me your age, tell me which class you're studying, and preferably you can also tell me which state or city you're joining us from, so that we know how many states are represented in this astronomy masterclass. Awesome. Sriram from Salem, Tamil Nadu. Very good. Arush from Chennai. Nandika. Next time we should Skype. Okay, we would do that. Hitansh, hi. Hi, Yukta. Hi, Swara. Shreyan from Kolkata. Hi. Sujani, Akshara, grade 10, superb. Rishi from grade 5. Naveen, grade 7. Ridant from Jodhpur, Rajasthan. Siddhant from Mumbai. Shardul from Kolkata. Kapish from Varanasi. Nice. I think all four cardinal directions of India are kind of like represented. We have people from north, people from south, people from west, east. Very good, so good, guys. So happy. I think most of you guys have introduced yourself. That's so nice. A few are also joining us right now. Fantastic. This is a special edition because I'm not going to be taking. Uh, okay, so we have Dr. Moi Abbas, so who's joining us in another minute. Okay, very good. So before he joins, let me just ask you one other question. What is your expectation from today's learning? What do you want to learn from Dr. Moi Abbas? I know he's going to talk about the life cycle of stars, about everything about stars. He's an astronomer who does researches about galaxies, about star clusters. So, what is your particular expectation from him? If you have any particular questions from him, so if you can throw some light on what you are expecting out of this special edition, it would kind of be like very nice. We could set up that platform for him, telling that so this is what our students are expecting, and we could jump right in. Tell us about event design. Okay, life cycle of stars. That's good. Simulations. I'm sure he's going to show you guys a lot of videos and simulations. How the stars die. Okay, let us play Kahoot with me or Moya Bhasa. So we are who will let us play Kahoot? Okay, I think I'm gonna do Kahoot this time, and hopefully next time when Dr. Moya Abbas is going to be here, he's going to do Kahoot with you guys. He was most probably looking forward to do Kahoot, but I was like, hey, give me something to do during this masterclass. He's taking the bulk of teaching today, so I said, okay, let me please do the Kahoot, and I'm here. Okay. Fantastic. So Julie says some answers to the queries of my 7-year-old. So fantastic. How we have scheduled this masterclass is that we are going to segregate the topics that he's going to teach into 3 different topics, and in between topics we are going to have question answer session. So like all of you guys know, this is going to be an interactive session. You guys are going to ask us questions in the chats, in the comment box, and Dr. Abbas is going to take care of that, and he's going to answer most of your questions. Number one. Number two, he's going to be taking a topic. So let's say about stars, birth of stars. So he's going to talk about the birth of stars. He's going to tell you guys different phenomena, what happens during that birth of stars. And then when he finishes the first topic, he's going to give 10 minutes time for you guys to ask particular questions about that topic, okay, whatever we have learned so far. And then we are going to go into the next topic. So like this, we are going to have three different topics, and as soon as we finish up with all the Q&A, we are going to jump right into the Kahoot session. So today's Kahoot, we have somewhere close to 30 questions, so looking forward to see that. And today's Kahoot, we are not going to have any prizes. Remember, during the Astronomy Masterclass, it's all about learning, it's not about competing. So for prizes in the Kahoot, you guys have to join the Kahoot with the Learning Coach program that happens free on the last Sunday of every month. Okay, superb. Know more about information of stars and win Kahoot after that. Okay, fantastic. So Kahoot is going to happen at the last. So probably at about 7:20, we are going to start Kahoot. So till then, I want you guys to be here and start learning. So without further ado, I think we have most of the things what your expectations are. Okay, I know all of you guys are kind of like really interested to learn about stars. So without further ado, let me bring Dr. Moi Abbas online. So hold on. Okay. Hi, Dr. Abbas.
Hello, Vinod, and thank you for the introduction. And I would like to thank you and your Space Learning Club for all the events you have been doing to teach people about astronomy. And I would also, of course, like to thank all of the people who have joined us today on this masterclass about the life and death of stars. And I'm so excited because I was looking at everyone introducing themselves, giving their names, where they're from. It's really nice to have all of these people gathered together today for this talk about the life and death of stars. And I would like to tell all of you, those who are with us today, that as Vinod said, I will be talking about the stars. I will try to explain everything there is about the stars, of course. And this will be divided into three parts. The first part, I'm going to share my screen now. Is this okay?
Yeah, yeah. No,
Okay.
Doctor, before we get into setting the expectations, I've actually just brought you in and failed to give a proper introduction about you. Would really be happy if you can just give us a glimpse of what you have learned,
Yes.
what you have studied. I know some of the students have already been in a program with you, been in a live call with you. So
Yeah.
maybe you can just introduce.
Of course, of course. I, I'm Abbas, and I was a physics student, so I was always interested in science. And I was interested in mathematics and engineering, but mostly in physics. So when I graduated from school, I studied physics at the American University of Beirut. And when I was a student of physics at the university, I had a telescope. Like I started an astronomy club, and we brought a telescope, and we started looking at the stars and at the moon and at the galaxies. And I was really fascinated with the universe. So I have decided then to start, to study more and more about astronomy. So then I moved to USA, and in the USA, I was doing my master's degree in astronomy. I was studying something we call globular clusters, and today in this master class, I will tell you a little bit about globular clusters. So my job was to go to the observatory. We had a big observatory with a big telescope, and my job was to go every night from 8 p.m. all the way till 5 a.m. only to point the telescope to the stars and to take images. And it was very interesting experience because I had the chance to work with the telescopes to take images of stars, of nebulas, of galaxies, and that was really amazing. And after I finished my research in USA, I went to Germany. So in Germany, I went to Max Planck Institute. Maybe you know this term, Max Planck. Max Planck was
Yes,
a
yes.
very famous German scientist. So I went to the Max Planck Institute for Astronomy, and I stayed there for like 4 or 5 years, where I was studying the how our galaxy was formed. So probably you guys also know that our galaxy is called the Milky Way, and we live inside this Milky Way. But what we don't know is how was the Milky Way created, and how did it become so big, and why do we sometimes see very small galaxies compared to very large galaxies? And this is exactly what I do. So what I do is I use telescopes from NASA, from ESO, and from other places around the world, and I try to make maps for our galaxy. And in the last 5 or 6 years, I've been trying to see people and give presentations about space, about astronomy. We organize like stargazing events, public talks, planetarium shows, and many, many other things. And also, like, I always used to also invite astronauts who have been in space. For example, I invited the Dr. Donald Thomas. He was a NASA astronaut in space. And last year, I was selected in the astronaut program here in United Arab Emirates. So I was trained and assessed by, if you know, astronaut Chris Hadfield. Chris Hadfield is the one of the most famous astronomers, and I've spent, I think it was like 3 months with doing training with the astronauts. Some training was done in United Arab Emirates, and then we went to Star City in Russia. And like I did the many, many tests exactly in the same location where astronauts do their tests. So I was
Wow.
in the center of the astronomers, and that was really amazing. If you guys know, for example, the centrifuge, where where you sit down and then you get rotated and you have to do things. So I got the chance to do this. I wore the astronaut suits, I got their training. There's so many challenging things, you know. I think I was like you guys, maybe 15 years ago, and I've always dreamed of becoming an astronomer and an astronaut, of course. But I should tell you that if you really like this topic, nothing is difficult. You can always do it, and you can always get what you want. But what I have always noticed is that as to become an astronaut is a really tough job. Like, it's not easy at all. You need to be mentally fit, you need to be physically fit, you need to be healthy, you need to be clear in mind. But this is something I support all of you on doing. And right now I'm in New York University in Abu Dhabi, and I do research about space, about astronomy, about galaxies, about the universe, how was it created, and so on.
Wow, wow. We didn't know that you are, in the astronaut training before. So this was
Yeah,
something new even for us. So fantastic,
yeah,
fantastic.
yeah.
So I think I'm going to leave the session to you. So guys, okay, enjoy your, and I'm going to be, available. So anytime that you said, then I'm going to be there. Huh?
Okay.
Yeah,
Oh, thank you, Vinny. Thank you so much. Okay,
yeah.
let's start doing this then. Uh, okay. Hello, everyone. Now we're gonna start. Yes, so we're gonna start with the presentation with the talk about the life cycle of stars. And as I have mentioned earlier, this is something I'm doing with VNID, with the Space Science Learning Club. And as Vinod also mentioned, this will be divided into three different parts. The first part will be very general. In the first part of this class, I will tell you about what are stars, and how do they shine, and why do they twinkle, and why do they have different colors. And as I go through these topics, of course, I will be talking about some details in that regards. in the second part, I will tell you about how stars are born, what are stellar nebula, and what are globular clusters. And finally, I will tell you about the HR diagram, how do stars evolve with time. And I have noticed that one of you guys asked a question, how do stars die? And of course, at the last part of this presentation, I will be telling you more and more about how stars die. If you just give me one second, just give me 1 second. I want to fix something really quickly. Okay, everything is good now. Sorry. Excuse me, guys. Okay, so now I can continue with my presentation. So, the first question I want to tell you about is, where do stars live? I mean, this is a very general question, yet is a very important one. I mean, if you go out during the day and you look outside, you would, of course, see the sun. And one thing you should know is that our sun is one star out of billions of other stars we have in the universe. But the question is, where are these stars located? And perhaps some of you know that most of the stars we see in the sky are located in the galaxy we live in, which is what we call the Milky Way. And during a nighttime, when you go outside and you see all of these dots in the sky, one thing you should always remember is that all these points that you see in the night sky are nothing but stars that are very similar to our sun. But the thing is, they appear to be small is because they are so far away. Even some of these stars can be even larger than our sun, but because they are so far away, we see them as if they are really small. And one of the things I always wondered about when I was a little kid about this kind of, if you see you see at the middle of the picture, you see this strip of the Milky Way. This is the area that is full of gases, and this is something I will be talking about in a bit. Now let me show you this simulation. Assume you are on Earth, okay, and you have a telescope, and your telescope is pointed towards the universe. Let's see if we zoom in the universe, what things we will be able to see. What you are seeing here, so what you are seeing here is we are zooming into a random place in the universe, and every single dot that you see out there is something like our sun. And just like our sun has the Earth and different planets around it, you should always remember, guys, that every single star we have in the universe has also planets orbiting around them. So if we keep on zooming in, and again and again into the universe, into our skies, we reach this place. If you look, so I post the image now. If you look at this image, one thing you will notice directly is that you have different galaxies in this different image. And you should also know, like, perhaps 100 years ago, everyone in the world, they always thought that the only galaxy that there is in the universe is the Milky Way, is our own galaxy. But today we know that the universe is full of galaxies. And in this zoomed in image, I show you some of these galaxies that you can see to the right. You see one to the left, and you see one all over this image. Now, I know that I'm aware that the Masterclass is more about the stars today, but I cannot really talk about stars if I don't talk about where stars live, and this takes me back to the galaxies. This is an image of a galaxy, You see, the center part of the galaxy, this central part, is where you have a supermassive black hole. And the black holes is something I will talk about later. But you also see that there are areas that are colored in red in this image. And this is what we call the disk of the Milky Way. And it is in the disk of the Milky Way that most stars live. If you see another image of a galaxy that looks like our galaxy, you can see this arrow telling you that you are here. You see how big this galaxy is? It is so large, it is so huge, and we are a very tiny small planet orbiting around a small star that we call the sun. Now I have a question for you guys, and you can just type your answer if you know it in the chat. Does anyone know how many stars? Oh, first of all, does anyone know what is the name of our galaxy? Maybe I have said it before, but does anyone know what is the name of our galaxy? Does anyone know? Yes, the Milky Way. Yes, the Milky Way. This is. Does anyone know how many stars we have in our galaxy? More or less, how many stars? Yes, I'm looking at your comments. Okay, I'm interacting with you. I'm looking at you. Yes, it's correct, Milky Way. But now I want to know how many stars are there in the Milky Way? How many are there? So let me tell you how many stars there are in the Milky Way because no one answered yet. Okay, so in the Milky Way, so I want you to think with me. Okay, yes, billions of stars. Okay, so I want you guys to think with me. All right. So we live in a galaxy that we call the Milky Way. And the Milky Way itself has 100 billion stars. Can you imagine that number? 100 million. It's even more than millions. So one galaxy has 100 billion stars. And when we look with telescopes all around the universe, we see that it has more than 100 billion galaxies. So the universe is so large that it has 100 billion galaxies, and inside every galaxy, we have 100 billion stars. And around every star, we have planets. So you can imagine how big this universe is. And our planet is only one tiny planet out of trillions and trillions and trillions of other planets that we have in the universe. So let me show you now another simulation based on real observation. Okay, so this is an image taken with a telescope, with Hubble Space Telescope, and it is so good that it can go very deep in the sky. So as you see the image moving inside the sky, you should always know that we are moving so many millions of kilometers away from our Earth. And again, look how many galaxies we see in this part of the sky. If you guys look at this image, you realize that there are so many galaxies in this image, and we call this the galaxy zoo. Just like you have a zoo of animals, why do we call zoo for animals? Because it's a place where you have so many animals. You have birds, you have fish, you have lions, kings, whatever. Also in astronomy, we have zoos of galaxies, and this is what we call a galaxy zoo because it is full of galaxies, and this is called the Virgo cluster. And I would like to someone, yeah, the game bro, yes, this is very true. It is called the Virgo cluster. Well done, game bro. Yes, now I want to also tell you I will answer your questions. I will answer all of your questions. Just let me get to part one, and then I will answer your questions. Okay? Yes, yes. Give me a minute, and like 10 minutes, and I will answer your questions. So I want to tell you one more fact about galaxies until we move to the next topic. The galaxies are made from three parts. Okay, this part at the middle is called the disk of the Milky Way. This is where the stars are located. The central part, which you see as a circle, okay, this is called the bulge of the Milky Way. It's like the center of the Milky Way, and there's the area that's around it. It is called the halo of the Milky Way. Now, this is not very important for you now, but I wanted to tell you about this because maybe next time we talk about galaxies and then you would know more about this. If you look at this image, you see many, many beautiful shapes of different galaxies that we have in the universe. But in this image, I only show you 40 galaxies. But always remember that the universe has more than 100 billion galaxies. And who knows, maybe it has even much, much, much more galaxies that we have ever imagined. Yes, so I want to show you another simulation. And I think this is a very important simulation. If you look to the right, you see the solar system. Every single point you see in this image are nothing but planets that are away from our solar system. Because you remember I told you we have 100 billion stars in our galaxy? And I also told you that around every star we have planets. Well, let me show you the planets that astronomers have discovered throughout the years. And let me ask you a question before I answer before I tell you about these planets. Does anyone know how many planets astronomers have discovered so far in the Milky Way? Does anyone know? I'm waiting for your answers. How many planets have we discovered so far?
Okay, Dr. Abbas, we had the masterclass on exoplanets last time, so let's see how many of them have got it right.
Yes, let's see.
Let's
200.
see.
So I will wait for your answers, and right now I will play the video. Look look how beautiful those planets are. We have discovered, yes, around 4,000 planets we have discovered so far. And in this video, in this simulation, I show you the locations of all the planets that we have discovered in the Milky Way in the past 30 years, because it is so strange, guys. You know why? Because astronomers have always thought that the solar system is the only system that have planets. But as we made bigger and bigger telescopes, we were able to find all of these planets that you see in this simulation. This is a very nice view about all of the things that we have discovered. Now I'm sorry for the very long introduction, but all of I have said right now, I didn't even tell you about the stars. So let me ask you the question, what are stars? And I'm waiting for your answers. What are stars? If you wanna tell me what are stars in one sentence, what are they?
Dr. Abbas, it usually is about 10 seconds delay, 10 to 15 seconds delay between our relay and kids hearing it. So they will take another 10, 15 seconds to reply back to you. So, yeah.
Okay, Vin. Yes, stars are ball of gases. So I'm reading your answers now. Stars are ball of gases, correct. Luminous balls of gases, big balls of plasma, big clusters of gas. I think you all got it right. But let me ask one more question. What are the gases made from? What kind of gases? Can anyone tell me? So you are all saying they are balls and spheres of gases. So what kind of gases? Because There are so many different gases we have in the universe. So what gas? Is it nitrogen? Is it oxygen? Is it, I don't know, other type of gases? Helium. So many people are saying helium, some are saying hydrogen, but I want to say that Meg Joshi, this is the name I'm reading, got it right. Stars are spheres of gases mainly made from hydrogen and helium, and also they are made from other elements, but mainly hydrogen and helium. And this is a simulation that would really show you our sun, because if you remember, if you remember from what I have told you earlier, that our sun is like all of the other stars. And here you can see a video, a real video of our sun. Remember always also that the sun is so huge that if I bring the sun, if this is the sun and I bring little earth, the sun can fit 1.3 million earths. So you can imagine how big the sun is in our solar system. And if you would to travel, if you would to travel to any of the stars, this is how they would look. I just want to make sure to tell you that this, what I'm going to show you now, is not our sun. This is one of the stars that are found in the universe. It is very similar to the sun, and you can see those planets orbiting around it. Just like we have planets orbiting our sun, Jupiter and Saturn and Mars and so on, we also have planets orbiting around other stars. And if you ever think of a star, this is what you should be thinking about. This is how all stars would actually look. Here I just show you some of the nice visuals. You see, the sun is made from 70% hydrogen and 28% of helium, and only 1.5% of other material like carbon and oxygen and nitrogen and other stuff. You see, I want to ask you something, you guys. Does anyone know what are these explosions happening in this video? Like, let me play it. You see these explosions to the left? Does anyone know what do we call them? Well, these, yes, again, and yes. Aditya Yalagur, you are right. These are called solar flares. And I think solar flares are very interesting. And in this video, I will show you some solar flares, and I will continue to tell you about them. Just like always think of volcanoes. You know how we have volcanoes on Earth? Well, believe it or not, but at the surface of the sun, we have something like volcanoes. And volcanoes, when volcanoes happen, the surface of the sun explodes, and they send so many particles all the way to Earth. Now, just like our sun, and as you can see in these videos, has a lot of solar flares, the same thing happens with all of the stars we have in the universe. They all have these solar flares happening at the surface, because everything that happens to the sun also happens to the other stars, billions of stars that we have in the universe. This is another image of some of the solar flares we have. Now there's one thing I want to also show you. If I ask you, or if you think about what is the sun made from, can I really go to the sun and stand on it? The answer is of course not, because it is very hot. And if this is what you see here is the most zoomed in image for the sun. And look what is the surface of the sun made from. The sun is, it is you see on Earth. So on Earth, just like we have oceans and water on Earth, also at the surface of the sun we have oceans, but not made of water. We have oceans made from lava. And this is a very zoomed in image of the sun. You see, everything is like, it's like oceans, it has waves, they are moving. These are very, very, very hot hydrogen and very, very, very hot helium moving around the surface of the sun. And this is what we call granules. Now, why do stars shine? This is a big question. Does anyone know why stars shine? I'm waiting for answers. Yes, all what you said about solar flares and sunspots and magma is correct. So the question was, why do stars shine? Because, every time I look at the sun, it is so bright. It is giving so much energy. And you guys know that the sun is like 150 million kilometers away from Earth. And yet, if I stand under the sun for like 1 hour, I will be so hot, I cannot take it anymore. But how can it give so much energy when it is so far away? And what about stars? What about other stars? Correct, nuclear fusion. But what about other stars? Other stars are so far away that even light will take millions of years to get to Earth, and yet we can see their light. So the reason for why stars shine is, as you all have said, nuclear fusion. So if I want to give a definition of the stars, they will be the following. Listen carefully, okay? Stars are spheres of gases that are mainly made from hydrogen and helium, and they are so hot that at the core of stars, at the center of stars, we have fusion, nuclear fusion happening. Now, what do I mean by nuclear fusion? It's exactly that it is exactly that two two atoms combine together to form helium. Can you see my presentation? Yes, okay, now you can see it. So I was telling you that stars, let me show you. This is how stars are. This is the core of the star. This is the center of the star. I want to tell you that all of this light that we receive from stars was created at the core of stars, at the center of stars, by what we call nuclear fusion. When I say nuclear fusion, it means that I get a proton, a hydrogen atom, and then I get another hydrogen atom. And when two hydrogen atoms, they are brought together, they fuse and they merge together, and they form a new element, which is what we call helium. And when this happens, when two hydrogen atoms, they merge together and form a helium atom, one more thing is also created other than the helium, and that is light. So this nuclear reaction, this nuclear fusion happens only at the core of stars. And in here, I want to show you, I want to take you inside the star. I want to take you to the center of stars so that you can see what really happens. So this is the star. We're going inside the core of the star, and look, watch carefully. This is the core of the star. What is happening is that there are so many protons swimming and moving in all directions. And I pause the video because I want you to see these protons will now come together, they will fuse and touch, and they will form a helium atom, and they will form the light that we receive from the stars. So this is how light is created. Light is created at the core of stars when hydrogen atoms fuse together to form helium and also light. See the light? This is the light I am talking about. This is amazing, guys, because this is how stars can live for billions of years. Now, before I go on, before I continue, I want to make sure I got it right. I want to make sure that you understood what I said. Where does nuclear fusion happens? Does it happen at the surface of the star, or does it happen at the core of the star? Waiting for answers. In the cores, yes. I'm so glad you got this right. Now I want to ask you one more question. How long, how long, how long does it take the light to come from the sun all the way to Earth? How long does it take? Waiting for answers. Yes, a deed jog. Yes, 8 minutes. Now, you know why I'm asking you? Because what I want to tell you now. So just to make things clear, yes, it takes 8 minutes for this light to come from the surface of the sun all the way to Earth. And I only ask you this. I knew that you know the answer, but now I want to ask you the more challenging question. You know, do you know how long it takes the light to reach? Because we agreed that the light is created at the core of the sun. So how long does it take the light to get from the core of the sun to the surface of the sun? And remember that the distance between the core and the surface of the sun is much smaller than the distance between the sun and Earth. So how long does it take the sun, the light, to get? No, not 10 million years. So let me tell you why this is interesting. I want to show you the picture. No, not 3 seconds. Well, Rock Gaming and Meg Joshi and Shiryan Avigyan. Sorry, I'm spelling your names in the wrong way, but this is very interesting. So let me tell you why. This is the sun, okay, and this is Earth, okay. It takes light 8 minutes to reach from the sun all the way to Earth, but it takes the light 200,000 years to get from the core of the sun all the way to the surface of the sun. And this is crazy because the distance inside the sun is much smaller than the distance between the sun and the earth. And the reason is the following. When fusion happens at the core of the sun, when fusion happens and light is created, light will try to escape from the core of the sun. And every time it tries to escape, it meets another atom, and that atom it pushes it in another direction. So the light gets stuck inside the core of the sun, and it takes it 200,000 years for it to escape from the core all the way to the surface, and then from the surface all the way to planet Earth. And if you look at this image, which I have uh, here for you, you see here, this is where at the center of the star is where the light is created, and you can see the photons, the light are going up and down, and then 200,000 years to get to the surface, and then 8 minutes to get to Earth. So what I want to tell you is the following. All the light we receive on Earth was created at the sun not 8 minutes ago, but it was created in the sun 200,000 years ago. And this is so crazy. Really, I think it's very interesting. So, this is a cool fact. Next, there's I still have one more part, and then we will be done with part one, and then I will answer your questions. Okay? Yes, 200,000 years, 40 Senia. Okay, so let me show you this. This is a telescope pointed towards the to the sky, and can you see this star? There's something changing in brightness and light. See, now it's gonna zoom in. You see, I'm zooming in more and more and more. What's happening to this star? Can anyone tell me what is happening to this star? What do we call this? Waiting for answers. What is happening to the star? What do we call this when we see it? There's a yes, twinkle. Yes, it is twinkling star. You know the song Twinkle Twinkle Little Star? This is exactly what we are seeing here. Now, do stars really twinkle? Do they really twinkle? The answer is most of them do not twinkle. Stars do not twinkle, but we see as if they are twinkling, not because they are twinkling, but more. Well, yes, yes. I'm seeing one of the comments. I do not want to confuse you. Most of the stars do not twinkle. Some of them do twinkle, but when you look from Earth and you see them twinkling, most of them are not twinkling. But the reason for why they are twinkling is because that uh, uh, our atmosphere, our atmosphere is making them twinkle. What do I mean by our atmosphere? So if this is a star and this is Earth, as the light comes from the star to Earth, the atmosphere of Earth will influence the photons, it will influence the light coming from the stars, and it will make us see it as if they are twinkling. So this is a star. See here, look to the left, a long path, more to the left. This is a star. As the light in yellow comes to our Earth, the light will go in the atmosphere, and you can see how now the light is doing, like this. So because the atmosphere is changing the direction of the light, so this is why we see them twinkling. Most stars, they do not do twinkling. Okay, now a question for you guys. What is the brightest object in the sky? What is the brightest thing we have in our sky from Earth? Does anyone know? What is the brightest? Sun, yes. Sun resh it. It's the sun. Not the stars, not the moon, not the moon. No, it is the sun. Correct. Now let me ask you another question. The brightest object, the most bright object is the sun. What is the second brightest object? What is the second brightest object? The first bright object is the sun. The second brightest object is not Ceres, not Jupiter. No, no, no. Not Ceres, no. So it is the moon. The first bright object is the sun. The second bright object is the moon. And then I know some of you said Sirius, the star, and Sirius is the brightest star, but it is not the brightest object. So look here, the sun at the top is the brightest object. The second brightest object is is the moon, and then Venus, and then Polaris, and then we have the other stars we have in the universe. Now, why am I saying this? If you look at this image right there, what you see is few stars that have blue color. This star, which you see with a red circle, I have put a red circle, is of course more bright than this star, which have also a red circle. But one thing I want you to know, and I want you to understand very well, that just because this star appears to be brighter than this star, so just because this star at the top is appears more bright than the star to the at the low part of the graph, it doesn't mean that this star is really bright. Maybe this star, which is very bright, is actually very dim. Dim is the opposite of bright. Maybe it is very dim but very close, and maybe it is very bright but very far away. So what I'm trying to tell you is the following. Let me put an example for you. Okay, I'm gonna try to make an example. If this is a star, this is a star, this is light. Okay, if the star is very close to you, if the star is very close to you, you will think it is very, very bright and big. But if it's very far away from you, you will think, if it is very far from you, you will think that it is dim and small. But this is not the case. What I'm trying to tell you is sometimes stars are very small and dim, but because they are close to Earth, they appear to be very bright. You can never tell, you can never tell if the star is really big and bright unless you know if it is far or close. Yes, Rupali 1276, it is Pleiades and it is the Seven Sisters. Bharati Maher, I'm sorry about your eyes. I'm sorry about your eyes. I wanted to show you. I wanted to show you how this works. Now I have a question. Well, not a question. If you look at this image now, you notice that we have many stars in here, but they have different colors, right? You see this star is red. You see this star is red in color. This one is more yellow in color, while this one is blue in color. Why do stars have different colors? Can anyone tell me why? Are these stars having different colors? Why is one red and one blue and one yellow and one I don't know what? Why do stars have different colors? Can you answer me? Yes, yes, it's true. Because of Yes, it is because of their temperatures. You see, this is an image that you see. Well, the answer, before I go on, the answer is in their temperature, and I will tell you more about it. What you see here is many stars. You see the sun to the left, it is very tiny, and then you see some blue stars, Deneb, the Pistol star, Ruby star, and also Antares to the right. See how Antares is a very huge, big star, is very interesting. So one thing we know now is that stars have different colors because stars have different temperatures. Stars also have different sizes. Some are very large, some are very small. And what I want to tell you about the temperature, let me show you something. Okay, let me show you something. Usually, guys, blue stars are very hot and yellow stars or red stars are colder. Let me show you why so. If I turn this on, look in this camera, right? You see that there's a blue color. Oh, no, not working. Let me use a lighter then. See, if you look here, you notice that the blue color is at the bottom of the lighter, okay? And as you go upward, you notice that the color is going to yellow. Why? Because at the bottom part, it is very, very hot. And as you go upward, it is getting colder and colder. So, red stars are cold and blue stars are hot. And if you ever forget this, get a lighter and turn on the lighter and look about the difference of the temperature. As you go upwards, the temperature drops and decreases, and this is why we have different parts. Now, the last thing I want to show you, in this part, it's a question. What is the color of our sun? What is the color of our sun? Waiting for answers. Yes, white, white, white. Correct, correct. Not orange, not green. It is white in color. But what you should know is that our sun is made from all different colors. It is green and blue and yellow and red and orange, and all the colors we have are also included of the sun. But when you mix all colors together, you get the white light. And let me show you an experiment for this. Do you see this wheel? This wheel is made from different colors. Now, if I rotate this wheel, you will see how the colors will mix, and then you will see it white in color. Look carefully. See, it's rotating. You don't see the colors anymore. You only see the white color. And this is exactly what is happening with our sun. Our sun is it has all different colors, but because all colors mix together, you see as if we have a white star. So this was the first part of this class, and if you want, I could answer questions, or tell me what you prefer, you want to do.
No, probably we can just take a couple of questions from the kids, and then we could go on to the next session, because we
Okay.
have another 30 more minutes, and then we have to start with the Kahoot.
How long?
30 minutes.
Yes, yes. Okay, good.
Yeah. Guys, if you have any questions, please, post down your questions. Probably doctor will take it now.
Yes, so I will answer quickly. What are neutrinos? Neutrinos, I told you before that you have protons, they fuse together, they form helium and light, and they also form something we call neutrinos. Neutrinos are very tiny particles formed by the nuclear fusion at the core of stars. Are humans and stars made up of the same gases? Yes. We humans are made from atoms and molecules that came from stars. Very true. Are there any aliens? Dive to knowledge. Are there any aliens? It's a good question. Well, statistically, there should be some kind of life, but have we ever found aliens? No. Are there aliens on Earth? No. Are there any sort of life in the universe? No one knows. Maybe there is, maybe there isn't, but maybe there will be. Maybe we will find something. But because no one has ever found anything, I can't give a final answer. Why do we see the sun yellow? Because of our atmosphere. Because when the white color is coming from the sun, the atmosphere blocks the blue color, and then it allows the yellow and red color to come. So we see it as yellow or red. How a nebula is formed? Abur Van B, I will tell you right now how nebulas are formed. This is the second part of the talk. Yes, I will tell you about nebula now, of course. How do we get light year? Every day when the sun passes light, the sun doesn't. Well, the light year is a unit of distance, remember. It's not a unit of time. What will happen if the sun die? What will happen? We will die, honestly. We will all die when the sun dies.
Okay, I'll just take a quick minute, guys. I want to give you guys a small feedback. Please don't post the same comment again and again. So I know a lot of people are posting, so it doesn't mean that you can post the same comment 20 times to get noticed. So for sure, if you're going to post your comments 20 times, I'm just taking care of the technicalities. I'll just remove you from posting for another 10 minutes. So please don't make me do that. Post your comment once, so definitely we'll answer all your queries.
Yes. Also, I want to tell you something, guys. So the class is not over. Now I will tell you about how stars are born by stellar nebula, because many of you are asking, and then I will tell you about how they die. But the first part was only about what are stars. So here's the most exciting stuff is coming now. So if you have questions about the first part, ask me. If you have questions about other topics, I think you should leave it till the end, just because I want to finish all the slides. Which is the biggest galaxy? Andromeda is not the biggest, but it is bigger than our Milky Way. There are so many other bigger galaxies in the universe. How is nuclear fission formed? Nuclear fission is the opposite way of nuclear fusion. Nuclear fission is when you break an atom, while nuclear fusion is when you create an atom. How stars die? I will answer you, of course. I will tell you all about how stars die. Okay, so I will move on. Okay, I will tell you about how stars are born and how they die. Okay, and then I will answer all the questions, even if they are related. Okay, so the second part of this talk is about the birth of stars. Now, I will not ask you how stars are born, because I think you all know that stars are born by what we call a stellar nebula. But I want you to always think of a stellar nebula as a cloud of gas. Think of the clouds we have in our sky. Think of the clouds we have when it rains. When you look up, you see a white cloud, and then it rains. Now, these clouds are usually big, right, in our sky. But you have to know that there are clouds that are trillions and trillions and trillions of times bigger than the clouds in our sky. And these clouds that are billions of times larger than our clouds are found in the universe. They are found in galaxies, in the disk of galaxies. This is an example of one of the galaxies. It is one of the nebula. It is called the California Nebula. You see, it has a very nice, beautiful shape, and this is what we call it, a California Nebula, because it does look like the California state in the USA. It is so large. It is so large. If you were to travel from one point all the way to the other point in this cloud, it will take you guys millions of years using the fastest rocket human has ever invented. And usually these clouds are made from hydrogen and helium, because stars are made from hydrogen and helium, remember. So if you have a huge cloud of hydrogen and helium and it collapses because of gravity, all these gases will be compressed into a small volume, and this is what we call a star eventually. Now, I want to show you more of these clouds. This is another zoom in image for one of the beautiful, beautiful nebulas we have in the universe. Why is this special? Why am I showing you? Because you are right now seeing the birthplace of a new star. This is how stars are formed, and the this is how new stars are being formed. Now, look at this other beautiful nebula. It is called the Heart Nebula because it does look like a heart, right? Again and again, remember, nebulas are clouds of gases made from hydrogen and helium. When they collapse, when they close on their own gravity, they form a spherical ball, which we call stars, because they do nuclear fusion at their cores. And I can show you many, many of these beautiful shapes we have in the universe. Now, I want to show you with the telescope. We point the telescope to the ring, to the Lyra constellation. See, this is the Lyra constellation. Why is the Lyra constellation so special? Because it contains the ring nebula in Lyra. So when I zoom in more and more, look what I will find. I will see all of those stars which we have talked about, but most importantly, in this section, we will be able to see what is this? Does anyone know what this is called? Does anyone know what this nebula is called? Waiting for answers. What is the name of this nebula? Yes, Meg Joshi, it is the Ring Nebula. It's a beautiful nebula. These are gases that have escaped from that star. This is the Ring Nebula, correct. Here I show you simulations of how nebulas, see, these are gases that are moving all over in the space, and they are, combining together to form larger clouds, and eventually all of these gases will be compressed into a smaller volume, and this is how stars are born, guys. I'm showing you now how stars are born. And this is another nebula, the Orion Nebula, which is made from gases again, forming new stars. Just like babies are born in their mother's womb, stars are made inside nebulas. And here you can see all of these gases that are really, really large, compressed and forming newer stars. This is how our sun was. You see the gases? You see there's a star, new star forming here at the center. You see it? It's forming. This is the birth of a new star. This is how our sun was born. This is how all of the stars in the universe was born. And this is the case of everything we have in our universe. And just that when when you look at the images of galaxies, you see these parts that are red and pink in color. This is where you have nebula, and nebula is where stars are being born. How long does it take a star to be born? This is a question, good question. Well, it takes millions of years for stars to be born, and then it takes them billions of years as they live. Why are stars spherical from aether? Stars are spherical because because of the force of gravity, because gravity tries to crush everything to the center, so it is always a spherical shape. How was the sun born from Shaggy pipes? It was born from a cloud of gas. So, a cloud of gas, if you have a cloud of gas, very, very large one, once it is very heavy, gravity will compress it. And as the hydrogen and helium are compressed, what starts at the center is the nuclear fusion. Once you have a nuclear fusion, you start having a new star. And I want to tell you that as the star is being born, some gases cannot make it to the center of the star, so they will be outside the star. And these gases that didn't make it to the center of the star will eventually become our planet. So are uh, our planet is made from the same nebula that formed our sun. Idiobotics. So, sir, what will happen to the nebula when two nebula collide? A good question. If you have nebula and you have another nebula and they come close to each other and they merge together, what happens is that they form a larger nebula, so they form a larger star. And one thing I want to tell you at the end of this part two, I want to tell you that when nebula collapse and form stars, another force tries to push the nebula upward, and this is what we call the pressure force. So when stars try to be born with the gravity trying to go to the center, what happens is that the pressure of the gases tries to expand the star. So there's always a war between gravity, which tries to compress the stars, and pressure, which tries to make these stars larger and larger. And the what I wanted to tell you also is that usually star when a nebula collapses and forms a star, it doesn't form one star, it forms many stars. And this is what we call binary stars. And if I show you that sometimes one cloud of gas forms many stars, it can form millions of stars. And what I will show you here, this is an image of what we call globular clusters. These are 1 million stars born at the same time from the same cloud. So think if any of you have twin brother or twin sister, these 100 million stars are twins because they were born at the same time from the same cloud. And finally, you can see here that this star is doing this. It is pulsating because gravity is pulling it to the center and then pressure is pulling it away. So it does what we call pulsation. So this was the part 2 of this talk. I will take few questions now, okay? Just few questions because I want to go to the last section and then I will answer all your questions. And guys, always remember that there will be a Kahoot quiz. So I'm telling you information which you need to answer later. Some of the questions will be simple, but some of them will be challenging. So be careful. Okay, so let me answer some questions. Are stars too hot or too cold or in the middle in the temperatures? Well, some stars, this is from Rupali, some stars are hot, some are cold, some are in between. So there are different, this is why they have different colors, because they come in different temperatures. Okay, Recha is asking how stars die. I will tell you right now in the third section, because the first section was about what are stars. The second section, how stars are born. And now in the last section, I will tell you about how stars are, how do they die. Okay, so back to the question. What are the dark portions of the sun? They are called sunspots. They are areas at the sun that have low temperature. What is hydrostatic equilibrium? From Sherian Avigian. Okay, good question, but I didn't want to talk a lot about this. But hydrostatic equilibrium is when you have the gravity force that is trying, to compress the star equal to the pressure force trying to expand the star. If these two are equal, then you have hydrostatic equilibrium. Any planet have human? Sanjit, does any planet have human? We have never discovered any planet that has humans. Why light is not visible on its path? Oh, good question. It can be visible if it is very powerful. Think of lasers, Vidya. If you think of lasers, you can see green laser, you can see its path. So you need very powerful light. How do stars die? From Rubit, I will tell you in the second part. So where is the nebula? Sir, what is the nebula's name where the sun was formed? It is called the solar nebula. Our nebula was called a solar nebula. Have we ever seen the solar nebula? Of course not, because it was already used to form the sun and the planets. What happens when two stars collide? Nice question. When two stars collide, there would be a war between them. So they crash together and the larger star usually wins. But usually stars do not collide. They are very far from each other. Human can survive in other galaxy? Well, it really depends. If there's a good atmosphere, good temperature, if there is liquid water, then yes. But Who knows if there are planets that have good conditions for life? What determines the temperature of the star? What really determines the temperature of the star, which is a very good question from Emmanuel Joshua. Emmanuel, what determines the temperature of stars is the size of the star, mainly the radius, and also the age plays a major role in the temperature of star. What is the coldest and hottest star ever known? There are many of them, really. There are some stars that are really, really very hot. And the coldest stars, Nita Adlaha, the coldest star are called brown dwarfs. Brown dwarfs. I will tell you about this. Okay, so let me know. Well, just for the people asking about the collision of stars, you should know that stars doesn't happen many times. So I want to move now to the third part of this presentation, and I need your attention. I will move fast. I will move fast. Okay, but I need your attention because this tells you about two things: how stars live and how they die. So be careful and listen carefully because next will come the Kahoot questions. So this is what we call the HR diagram. HR diagram. What is the HR diagram? The HR diagram is a diagram which has temperature on the x-axis and luminosity on the y-axis. You might ask me, what is luminosity? Well, luminosity is the brightness of the stars. If the star is very bright, then it will have high luminosity. If the star is not bright, it will have low luminosity. Okay? If you look to the right of this graph, okay, you see our sun right there. You see the location of our sun. We call our sun to be main sequence star. You see this. If you look at this main sequence branch, all of these stars next to the sun are called main sequence stars. Main sequence stars uh, are the uh, are the young stars. These are the stars that have many years to live. These are the stars that are fusing hydrogen to helium at their cores, just like we have discussed before. And in fact, I want you to read these. 90% of the stars in the skies are main sequence stars. Again, these are the young stars, and most stars in the sky are main sequence stars. The sun is a main sequence star. And when a star is born, it is born when a star is born, it is born at the main sequence star, at the main sequence branch, and then it starts as it burns hydrogen to helium, it moves in the main sequence branch. But at some point, there will be no more hydrogen for the star to fuse. So what happens then? What happens is that the sun, when it has no more hydrogen to fuse, the core of the star will collapse and the radius of the star will increase. So it will become a giant star. It will jump to the giant branch. It will become much larger. And the temperature will decrease. So it will become colder than how it was when it was a main sequence. So when the star is a giant star, what happens? Remember, it has no more hydrogen at the core. So what happens is it will now fuse and it will combine helium to carbon, and then as it combines helium to carbon, it will have no more helium to fuse, and then it will throw all of the gases away and it will become a white dwarf. Don't worry, I will repeat this one more time, but I need you to be careful because this is very important. Let me show you this. Look at this. at the upper part. Forget about the lower part. So I have a stellar nebula. The stellar nebula collapses. It forms a protostar, a baby star. Then the baby star, it will start fusion, so it becomes a main sequence star. I'm talking about the upper part of this diagram. Forget about the lower part for now. So it will become a main sequence star, like our sun. So this is a main sequence star. It will be fusing hydrogen to helium, but when it has no more hydrogen, the star radius will increase. It will become a giant star. When it become a giant star, it will start to pulsate. It will throw the gases into space, and it will become a white dwarf, as you can see here, and a planetary nebula. Now, let me show you how this really happens. Look, our sun will become like this. Our sun will become like this. It will become a planetary nebula. And this is how it will happen. Look how our sun will die. This is our sun. This is our sun. It is now a main sequence star fusing hydrogen to helium. But at the end, it will not have hydrogen, so the radius will increase. Look, now it's a main sequence. Now it's increasing in radius. It's becoming a red giant star. And now it will throw all the gases and it will die out. See? No more sun, no more life. And this is how the sun will die. And what will be left is what we call a white dwarf, right there at the center. This star that is left after the death of our sun and of other stars is called a white dwarf. Remember that term. Okay? Now let me tell you one thing. What happens is the following: if the sun is very if the sun is like our sun, which is not very heavy, it will die, it will become a giant, and then it will become a white dwarf. But if the star was very massive, it will not become a giant, it will become a super giant star. And let me show you that. You see, I'm back to this graph. As the star moves on the main sequence, once it has no more hydrogen, if the star was very large and big, it will become a supergiant. And you can see this at the upper right of the graph. Supergiant star is even much larger than a giant star. And these stars, you can see supergiant stars here. And these stars, they do not turn into a white dwarf, they actually explode with what we call a supernova explosion. And you can see that supergiants are really, really huge and massive. And right there, you can see a supergiant branch compared to a small star that you see. So these stars that you see here that are really, really massive, they die with the supernova explosion, and this is a supernova explosion. When a star dies with an explosion, it is because the star was very, 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 very massive. If the star is not massive, it doesn't do explosion, it turns into a white dwarf. Yes, this is a supernova explosion, and this is what we call the Crab Nebula. Awesome. Now, when a star dies with an explosion, there are two different scenarios. Now, I want to go back to my picture here. So, if I look now at the lower part of the graph, a nebula forms a protostar. A protostar forms a red star, which means it's very massive also and very hot. A very massive stars turn not to giant, but to supergiant. and the supergiant turns into an explosion, the supernova explosion. And the supernova explosion, it will either become a neutron star, or if the star was very, very, very massive, sorry, or if the star was very, very, very massive, it will turn into a black hole. So the most massive stars in the universe turn to black holes. The little bit that have less mass turn into neutron stars, and the ones that have even less mass turn into red giant and white dwarfs. This is to brief things out, guys. We have a nebula. I'm gonna say this one more time. We have a nebula. A nebula is made from hydrogen and helium. It collapses. Once it collapses, it forms a protostar. And then, if this star wasn't so massive like our sun, it becomes a main sequence star. It fuses hydrogen to helium. When it has no more hydrogen, it gets larger and becomes a red giant, a giant star. When a giant star dies out, it pulsates, it throws the gases, and it makes a white dwarf. Now, those gases that the star has thrown, it will become a nebula, which later on will form another star. Now, if the star which was born from a nebula was very massive, it will become a supergiant, and then the supergiant will become an explosion, a supernova explosion, and the supernova explosion will become a black hole if it was very, very, very massive. If it was a bit less massive, it will become a neutron star. A neutron star, a neutron star is a small, it's kind of like a white dwarf, but it is made from neutrons. If you know chemistry, you have the atom, it has neutrons, electrons, and protons. So a neutron star is a small star that is only made from neutrons. It has so much gravity that it can accrete everything around it. It is so much heavy that one spoon, if you go to a neutron star and you take this much material from a neutron star, this much will weigh like 2 mountains on Earth. So it has a very high density, very high gravity. And if you want to brief things out again, a fetus, when a human is born like a fetus, it's like a protostar. And then as you increase with age, you're becoming a baby, and then you become a young person in the 30s and the 40s. This is what we call main sequence of stars. This is when hydrogen is fused to helium. When stars is getting older and dying, they become giant or supergiants. And eventually, when stars die, they become white dwarfs or black holes or neutron stars. The more massive the star, the more massive, the faster it will also die. I just want to show you this example. This is a black hole and this is a star. And you can see how a black hole, because it has so much mass and gravity, you can see how it can accrete and eat the gases from the nearby star. I would also like to show you, this is a black hole moving next to a star. You see, this is a black hole because it has so much gravity. And remember that this black hole was created with a supernova explosion. And this black hole is moving all along the star, and it distorts the light coming from that star. Amazing, powerful black holes. Black holes are so powerful that they can change the direction of light, and they are so powerful that they can change the direction of time, because you always have to think of time in the scientific point of view. And finally, this is the last thing I want to show you. Look and see how many stars one black hole can eat. Wait for it. The first part, so if you want to create a black hole, you need to compress something very big into a small volume. But this is not the important point. This is the important point. Look how massive the largest black hole is. All of these stars, that you see in this simulation are all contained in one black hole. And we know today that one black hole can eat millions of stars. And always remember that every star is millions of times larger than planet Earth. And planet Earth is millions of times larger than every single human being. So just think of the size of humans in comparison to anything we have up in the universe. So thank you for your time. I will answer your questions now, and then we can go for the Kahoot quiz and see how this will go. So I will start to try to answer your questions. Sir, how can we check that after the explosion of the nebula it would be a black hole or neutron star? This is from Edubotics. It's a good question, Edubotics. If the mass of the star is extremely large, it will become a black hole. If the mass of the star is a bit less massive, it will become a neutron star.
Dr. Abbas, you can actually close down your screen share so that you can see the questions in your screen itself.
Okay.
Yeah.
Okay. What will the sun be if it dies? The sun will become a white dwarf when it dies. It will create a white dwarf. What happens to a white dwarf? Good questions. A question from Ramya R. Well, white dwarf are like the dead corpse of humans. So when we die, they bury us, and our body dissipate. So white dwarf will eventually get colder and colder, and then they will die out, and nothing will happen to them. So they will just get colder with time, but it will take them millions of years. Do nebula die? Well, the nebula, remember, they are not alive anyway. Nebula form stars. So you might find nebula there for billions of years without forming any star. How are white holes formed from Swaroop J? Well, Swaroop, there are no evidence for white dwarfs. They are still theoreticals, but it is believed that white holes are the opposite of black holes. So when you have a black hole here, you will have another hole, which what we call white hole at the other end. But this is not very proved yet. Are there more than one Earth? Well, there are many, many, many planets. There are trillions and trillions of planets in the universe. Is any of them like Earth? I don't know. You know why? Because we haven't seen one yet. Maybe yes, maybe no. We can't tell. No one can ever tell you. How much time will it take to colonize Mars? I think it will take humans, like, to send a human to Mars, not to colonize it, but just to send a human. I think we need like 30 or 40 more years to send a human to Mars. From Rock Gaming, sir, can a black hole destroy a galaxy? Well, I don't think so. No. Well, black hole can destroy gases, stars, and other stuff, but a galaxy is made from millions of black holes anyway. So I think galaxies are more powerful. Does supernova emit radiation from Aditya Yalagur? Yes, a lot of radiation. Supernova are the most violent explosions in the universe. Uh, Supernova give energy more than 100 billion stars when they happen. So a question from Hirishi: how far is to increase interest to 8-year-old in astronomy? Well, I think is this the question? Sir, what will you suggest to increase interest of 8-year-old in astronomy? I think just more interest in science, maybe watching videos on YouTube, reading, getting some books, and eventually, if the kid likes science, I think the second step would be going to college for physics or engineering or chemistry or something like this.
Dr.
Can
Abbas,
you? Yes.
can we do the Kahoot and then probably at the end you can come and talk to us for another 5 more minutes?
Of course, of course.
Okay, so why don't you're going to join us for the Kahoot, right?
Yes, of course.
Okay, so why don't you grab a cup of tea or
Yes.
coffee, have a bit of refreshment for yourself. So the session was kind of like fantastic and too many questions. So I'm just curious
Mhm.
and excited to start the Kahoot. And let me take them through the Kahoot, and you can join us, and we'll take some more questions at the end of the session.
Okay, all right. Sounds good.
Okay.
Okay.
Yeah. Yeah. Okay, guys. So let me start with the Kahoot. We'll go to the Kahoot and then come back to some of some more question and answers. Okay. So before we go into the Kahoot, I have a small information for you all. Okay. First and foremost is that I want to share with you guys about the Ultimate Guide to Space Science program. So I know a lot of you guys have already been part of the Ultimate Guide to Space Science over here. But if you are interested in space science and astronomy, and if you want to know more about how to become an astronomer, how to become an astronaut, how to become a space scientist, this is a great opportunity. So this is a 6-day interactive course. Okay, and the next batch is going to start on 9th. So today is 10th. Sorry, today is 11th. In another 8 days, we are going to start next Monday. We are going to start the program. So in this program, we teach you, what space science is all about, what space research organizations like the ISRO, like NASA, they do, how to get to work for them. I know a lot of you guys would have a dream becoming an astronaut or a space scientist. So we'll guide you on how to get there, and a lot of different things are kind of like planned in that course. So the course consists of different elements. First and foremost, you have an interactive lessons where I teach you guys, about different things in science. Every day there will be, assessments, quiz, and as you know, our programs are based on steadfast learning. So steadfast learning is based on, the assignments that you do. So how well you become creators, and as you with regards to all our programs, we finish the last day with a Kahoot session. Okay, so this is how the course is kind of like planned. The next session starts on 19th, and you enroll for the program for just 799 rupees. That's 800 rupees. So this is going to be a 6-day program. Starts on Monday and ends on Saturday. Okay. So looking forward to having you all in this program. We'll send you more information about the program along certificate link. So with that, let me quickly show you the Kahoot screen. Okay. So here is the Kahoot screen. So please visit this web page, kahoot.it, and enter the game pin 5391116. That's 5391116, and enter your real name. Yes, those who want to know more about it, we will send you information about the program along with in the WhatsApp. So how you got your link, we'll also send you information about the Ultimate Guide program. Those who want, you can enroll for that. Oh, that's nice. Guys, to play Kahoot, you got to be live in 2 devices at least. Okay. So please visit webpage kahoot.it, and then it's going to ask you for the game pin. Please enter this game pin. After you enter game pin, it's going to ask for your name. Please write down your name. Don't write, some names. So here you have entered just the game pin. I'm sending you out. Please have your name there. I am 7. Please change your name. Guys, I have sent some of you out. Please change your name so that I know exactly who you are. Nice. We have 66 people joining. In another 2 minutes, we would start the Kahoot at 7:45 exactly. So this Kahoot, the questions were actually prepared by Dr. Abbas, and it was, all about all the topics that you learned during the masterclass. Pin, Bharti, the pin is 5391116. So you don't have to download the app from the Play Store. You can just visit kahoot.it, www.kahoot.it, and then enter the game pin. It's a web-based game, so you can. What would happen is that you would see the questions in the YouTube screen, and in your mobile you would only see answers. So you would see the questions, and then you would answer in your mobile phone based on how fast you answer and how right your answer is. For every thing, you would be awarded 1,000 points. Okay, that's nice. We have 91 who have joined us. Could we join with a round number of 100? Could we start? So as soon as you enter your name, it's gonna say you're ready to join. So be there in that screen. As soon as I click on start, the game would start. 93. Okay, 95. Last one more minute, we would wait, and then we would quickly start on the next session. Okay. Okay. So those of you who are joining in late, you can just visit this web page, kahoot.it, and join the game. So I'm going to start the game now. It's all about stars. So the first question. So we have 20 questions. The first question is, most stars are made up mostly of which two gases? You have 60 seconds to answer this question. You have 20 seconds left. Most stars are made up of which two gases? Is it oxygen and nitrogen, carbon dioxide and hydrogen, hydrogen and helium, or nitrogen and helium. So let's see how many of you guys get it right. We have 88 answers so far. Okay, 71 of you guys got it right. Still, some of you think that stars are made up of oxygen and nitrogen. No, carbon dioxide and hydrogen. Definitely not, and not nitrogen and helium. Okay, it's hydrogen, helium. That's the right answer. So here's the leaderboard. Saravana Lokesh is on top of the leaderboard, followed by Prarthana, Mitra Shri, Ashutosh, and Dhruv. So good job, guys. So here is second question. No, I don't think Sir is playing because he was the one who created the quiz. Here's the second question. What color are the hottest stars? What color are the hottest stars? Guys, please don't answer in the YouTube video, or if you want to answer in the YouTube video, answer in the last 10 seconds. Before that, when the clock, you can type your answers, keep it ready, and when the timer hits 10 seconds, you can answer here. Till the time, please don't answer in the YouTube stream. What color are the hottest stars? Fantastic. 3, 2, 1, and 94 answers. So let's see. Very good, guys. So the hottest stars are blue color stars. So not orange color, not red, and definitely not white. Very good. Tana moves to the top of the leaderboard, followed by Mitra Shri. Meg is the new entrant into the leaderboard. Dhruvin is the highest climber. Good job, Dhruvin. Third question out of 24. Why do stars twinkle? Why do stars twinkle? Vibha, just refresh your page. You should be able to open Kahoot. Refresh your page. Refresh your Kahoot page and enter the game pin. Game pin is shown at the bottom of the page. You can see the game pin here and just highlighting it. It's all shown here. So you can enter this game pin and join. Why do stars twinkle? You will only see the options in your Kahoot. You will not see the words there. It will only be shown colors. So you'll have to look at the YouTube stream and then correspondingly you have to enter. Why do stars twinkle? Again, we have 92 answers. Wow. First three questions, I have more than 70 people, answering right answers. Fantastic. It's because of the Earth's atmosphere. Very good. Okay, another change in the leaderboard. Prarthana takes the pole position, followed by Dhruv, Meg, and Joshua. Adit is up 23 places. Nice. This is the fourth question out of 24. Which one of the options represent increasing level of temperature from coldest to hottest? Which one of these options represent increasing level of temperatures from cold to hottest? Twenty-two seconds left for. Is it blue, yellow, red, or red, blue, yellow? Red, yellow, blue, and yellow, red, blue. Which is if you find the coldest one, it's much easier for you to answer. Remember, the lighter from top is the coldest one. Very good. So red, yellow, blue is the right answer. From the bottom, you have hot. So blue is the hottest. and red on top is the coldest. So you can find yellow and orange in between. Let's see if there is any change in the leaderboard. Meg takes pole position. Joshua and Archie are new entrants. Very good. So let's go to question number 5 of 24. I'm hurrying up a little because we are almost kind of at the end of the session and the time is of essence. The brightness of a star depends on. Does it depend on how much hydrogen it has, or the brightness of a star, does it depend on how far it is, or of its size, or the number of planets? Remember, Dr. Abbas even explained this concept with the help of his mobile phone flash camera. Okay, last 8 seconds. 3, 2, 1, and let's see the right answer. Wow, how many of you guys got it wrong? He told you the brightness of the star would depend on its size, not on how far or how much hydrogen it has. Okay, new people into the leaderboard. Tough question, I believe. Ashutosh, Pratyush, and Abhishek are back, and Vardhan is the highest climber. Very good job. Okay, this is question number 6 of 24. A very bright star can seem to be dimmer because it is. Think about it and answer. Don't just answer like just like that. Parisa, if you have answer trouble in answering, don't worry about it. You can answer in YouTube. Okay. What generally happens is that it depends on a lot of factors. Right now, I'm also open in my YouTube. It's 18 seconds. Whereas in YouTube, it's showing me as 28 seconds. So there is probably a 20-second delay between I'm showing you the question and you are able to see the answer. Okay, this is because of network issues, broadband connectivity, and lot of different parameters. So don't worry about it. If you are not able to participate in Kahoot, you can answer here. So why we do the Kahoot is for you to do a refresher of what we have learned in the course. It's a much easier way of refreshing what we learned in the course. Very good, guys. It a star's bright. A bright star can seem dimmer because it is further away from us. Okay, very good, superb. Darshan is the new entrant into the leaderboard, and Chiru is the highest climber, 30 places. Try refresh. See if your times the problem would be if your YouTube is not running on live. Just check if your YouTube is running on live. If your YouTube is running on live, you should probably have about 10 seconds delay, not more than that. Yukta, the questions for the Kahoot is shown in the YouTube video. So you need two devices to play. Look at the YouTube video and answer in another device. If you are watching this in a laptop, you can open two tabs. You can probably have two windows open. Resize them in such a way that you are able to see both the YouTube and the answer window in the same screen. What are in galaxies? Let's see how many of you guys say stars and ice. Wow, very good. Only 5 of you guys say stars and ice. I was rooting that most of you guys are going to choose stars and ice, but good thing. So you have dust, gas, and stars in galaxies. Very nice. Okay, no change leaderboard, but Advik is making a comeback with 3 in a row. Good job, Advik. So here's our first true or false Question: the nearest star to our planet is 4.2 light years away. Yes, a split screen option for mobile phones is also a good option. The nearest star to our planet Earth is 4.2 light years away. Is this true or false? The star which is 4.2 light years away is called Proxima Centauri. Is that the nearest star to our planet? So let's see how many of you guys think it's the nearest star, and let's see how many of you guys think it's false. The answer in 3, 2, 1. The nearest star to our planet is the Sun, not Proxima Centauri. Okay. Let's see how many of you guys lost the answer streak. Okay, Meg has taken pole position, followed by Pratyush, Joshua, Mitra Shri is back, and Archie is back. Okay, and 21 players have reached an answer streak of 3. That's nice, guys. I would really love you guys, a complete answer streak. Superb. So this is question number 9 or 10, I believe. So stars produce light in their surface, in their atmosphere, in their cores, or they do not produce any light. They just reflect light like planets and other celestial bodies. Again, Dr. Abbas, explained you very well this point on, where stars produce light. And he also gave an example of our sun, how light produced in the sun travels, how fast it travels. Let's see how many of you guys get it. U rays. There's nothing to lose here. So when you gain knowledge, you win. Very good. It's in their cores. Okay. It's in their cores that they produce light. Okay. No big change. Prasad is making a comeback with 3 in a row. This is question number 10 of 24. This is a multi-select. Actually, it's not a multi-select. It's a single select. At which part of the galaxy are stars usually born? At which part of the galaxy are stars usually born? Is it in the bulk of the galaxy, or is it in the halo, or is it outside the galaxies that stars are born, or is it the disk that stars are born? You have 22 seconds to answer now. Yes, guys, it's in the disk that stars are born in a galaxy. Okay, new entrants into the leaderboard: Sriram, Manikan, Aditi, and Krishnan. That's good job. Meg and Pratyush are holding on to the top 2 spots. This is a true or false question. Question number 11. Gas and dust in interstellar nebula can form black holes. Gas and dust in interstellar nebula can form black holes. Ashwani, answer in the last 10 seconds. But some people answer a lot faster. All they do is, tell the wrong answer so that others also follow suit. Let's not do that. Let's not give hope on both sides. Very good. The right answer is false. Good. Okay, so again there is a change. Dhruv is back into the leaderboard. Aditya back, and Kritika is back in the game with 3 in a row. We are at the halfway stage. This is question number 12 of 24. This is the most important property that determines how long the star will live. Is it the color of the star that decides how long the star will live, or its distance, or its mass, or its volume? Take your time, but answer in the next 8 seconds. The answers will be visible in 3, 2, 1. The right answer is mass. It's not the color, it's not the distance or the volume. Okay. Color only can determine color, you can determine how hot the star is. Not depends on what would happen to that star. Okay, Mitra Shri is back into the leader. No big change other than that. So this is question number 13 of 24. How are nebula formed? Every time when we plan masterclass, we plan, okay, we are going to do a 60-minute masterclass. It ends up at 70 or 80 minutes. Next masterclass, we plan for 90 minutes. It ends up at, 100 minutes. This time, planned it in such a way that, okay, let us plan for 120 minutes so that we end up at 110 minutes. But actually, we have gone past 120. So sorry, guys. Hope you guys are enjoying so far. Finish with the Kahoot. Okay, another 10 more questions, less than 10 more questions. Okay, okay. So nebula are not formed from the Big Bang. Remember what Dr. Abbas said? As soon as the star attains supernova and it explodes, its remnants are what forms nebula. Okay, so there's again a change in the leaderboard. Pratyush Dev is back with 3 right answers. Good. Another true or false question. Planets are formed from the leftover of the nebula that forms the stars. Is it true or false? Planets are formed from the leftover of the nebula that forms the stars. Let's see how many of you guys get it right. Ashwani, you can probably answer here. If you are not able to log into Kahoot, you can answer here. Okay, this is still a 50-50 question. Okay, 50% of you guys got it right, and other 50% almost got it wrong. So planets are actually formed from the leftover. Nebula has got gas and dust, and this gas and dust is what helps in planetary formation also after stars get formed. Okay, Aditya has taken the third place. Darshan and Sriram is back into the leaderboard, and Melita is back with an answer streak of 3 right answers. Very good, Melita. Okay, and Meg is holding on to the top of the leaderboard. So, what are globular clusters? What are globular clusters? I think when we saw the Pleiades cluster, we had this question of what globular cluster, how these globular clusters were formed, and stuff like that. Let's see if you guys remember that and answer the right things. Okay, so it's the collection of stars that are formed at the same time from the same cloud. So he was saying that these are all kind of like twin stars, stars formed at the same time. Those are globular clusters. Okay, Darshan, Sriram, and Joshua is back into the leaderboard. Advik is back with an answer streak of 3 right answers. Good job, Advik. Question number 16. A plot of surface temperature of stars against an absolute magnitude is called, we showed you a graph. What is this graph called? Is it called the spectrum or an HR diagram, a temperature plot, or the stars plot? Ashwini, let us know what help you need. Very good, guys. It's an HR diagram. Okay, no change. Dhruv is the highest answer streak of 8 right answers on fire. Good job, Dhruv. You need to get one right and Meg needs to get one wrong. Compare our sun to the rest of the other stars. How does our sun gets compared? Is it the smallest star in the universe? Is it a medium-sized star with medium temperature, or is it an extremely large star and very cold, or a small star with a medium temperature? Our sun, compared to the rest of the stars, our sun is considered what? Where the answer tick. See, you have to open up Kahoot, and in Kahoot, you will see only these 4 answers. You will see 4 colors. So, if let's say red color is right, you just have to click on red color. Once you click on red color, your answer would be noted. If blue color is the right answer, you click on blue color. Similarly, there will also be shapes shown. So, if it's red, it will show you as triangle. If it's blue, it will show you as a diamond. Likewise. Okay, right. So it's medium size with medium temperature. Let's quickly go on from here. Question number 18 of 24. A star that explodes is known as, a star that explodes is known as, Dr. Abbas is very curious to see how many of you guys got it right. Okay, more than 50% of you guys got it right. It's a supernova. When a star explodes, the phenomena is called as a supernova. Okay, Pratna is back and Siddharth Nirma is back with an answer streak of 3 right answers. Okay, this is a puzzle. Okay, you have to arrange the things in the right order. Life cycle of our sun. You have to arrange it in the right order. Life cycle of sun. Okay, there is some problem in the share screen, so let me quickly do my share screen one more time. Okay. You have to arrange the following in the right order. Yes, Yuris. I think the screen froze for some time. But don't worry, that's why I gave about 90 seconds time this question, luckily. So you still have 60 seconds time to complete it. You'll have to arrange them in the right order. Okay, the correct order is nebula, main sequence, a giant, and a white dwarf. This is how our sun would become. Okay, this is the life cycle of our sun. Okay, Darshan is back into the leaderboard. There's a huge competition between places 2, 3, and 4. A brown dwarf is a brown dwarf. Saina, it should probably start with a nebula and then be a main sequence. Brown dwarf, what is a brown dwarf? Is it a huge star? Is it a small planet? Is it a ball of gas that doesn't give light? Or is it a very hot and long living star? Serious, don't worry. We are not doing a comparison of who's there in the top 10, top 12, top 5. It doesn't matter. So what we are doing is we are revising whatever we have learned in the past 2 hours. So all that matters is that you take this knowledge with you forever. So that's what we are trying to do. Very good, guys. It's a ball of gas that doesn't give light. Okay, Navya, first time into the leaderboard. Good job. Advik is back with an answer streak of the right answers. So this is question number 21 of 24. We saw a brown dwarf. Now let's see what a white dwarf is. Is it a failed star, a star that was never born, or a stellar remnant, just like a human corpse, or is it a luminous star, or a star undergoing thermonuclear reactions? So Dr. Abbas is giving you a clue. He says it's not a failed star. So you have three options. Hope you guys know what options that you want to choose. Not go like, inky pinky ponky. Okay, the answers are shown right now. Fantastic, guys. So it's a stellar remnant. Okay, just like how a human corpse is. There's no life. So that's what a white dwarf is all about. Okay, no change in the leaderboard, and Shreyas, 3 in a row. Good job, Shreyas. Question number 22 of 24. What is the first stage in the life cycle of a star? What is the first stage in the life cycle of a star? What is the first stage in the life cycle of star? When you remember the life cycle of human beings? Technically speaking, I'm a super giant by this time. Very good. Okay, guys, that's a main sequence star. Nice. I hope some of you guys are, old enough to be called super giants. I don't know who are these super giants. Okay, dwarfs are probably infants, babies, and giants. Okay, giants are adults. Super giants are very old people. Okay, so no change in the leaderboard. 9 players have reached an answer streak of 5 right answers. That's a very good job. So this is the penultimate question. Question number 23 of 24. What is the smallest type of star? What do you call the smallest type of star? Okay, the answer would be revealed in 3, 2, 1. The smallest type of a star is the dwarf star. And 3 of you guys chose a black hole. Huh? Okay, Darshan is also back, and Sudhir Ram is making a comeback with 3 in a row. So this is the last question, guys. This is a puzzle where you need to arrange the correct order of the life cycle of massive stars. Okay, so the end of the massive star would be that of a black hole, but arrange it in the correct order. Any clue? It ends at a black hole, so it would probably start from the nebula, I believe. Okay, last 10 seconds. Okay, guys. It starts with the nebula, then it becomes a main sequence star, and then a red supergiant, and finally it becomes a supernova. From a supernova, it can become a black hole there. Okay, very good, guys. So let's see the leaderboard. In the podium, in the third place, drum rolls for Navya. She was nowhere seen until the 20th question. In second place is Drew, and in the first place is Meg. Okay, good job, guys. Very good job. So in the fourth and the fifth position are Darshan and Archie. So nice, guys. Let me stop. Okay. So once again, thank you so much. Hope you all enjoyed. So let me know in the comment box how was this masterclass. Okay, how was the special edition of the masterclass? Give us a rating from 1 to 10. 1 if you liked it, 10. Sorry, 1 if you did not like it, and 10 if you like it very much. Okay. So give us a rating from 1 to 10. I know we have exceeded probably about 25 minutes long. Okay, so I'm not going to take much of your time. Thank you so much. 10 on 10. Thank you so much, guys. Fantastic. So this video of the masterclass is going to be available until 11 o'clock tonight, or okay, I think my team is saying we can make it available until 11 a.m. tomorrow morning. Okay, after that video is going to be brought down. So please, if you want to do rewatch this session, please take your time before tomorrow 11 o'clock and watch this again. And as I told you, we have the Ultimate Guide to Space Science program opening next week. So if you are interested, you can enroll for that. You have a certificate for this program. The certificate would be WhatsApp to you tomorrow morning. So please do download your certificate. You can make your own certificate. It's a do-it-yourself certificate. So you can do that. And finally, I would like to thank Dr. Abbas. So he has graciously accepted to be host for today's event, and given mind-blowing facts about what a star is really. So we have all seen stars in the night sky, but right now I'm 100% sure your perspective about what the star is, what it has happened in its life cycle to become what it is today, would change with that. Okay, so with that, thank you so much, guys. Looking, if you have any queries, you can just post it as a comment in this thread, and we'll be more than happy to assist you with your questions. So because of lack of time, I'm going to end the session right now. We would get in touch. Looking forward to have you in future program. Okay, see you all. Bye bye.